Hello everyone, Dennis here. This is lesson number 8, Further Coordinate Geometry. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Let's start the lesson with learning the equation of a circle. So, let's say I have a circle drawn on a graph with the center C, coordinates of A, B, and this is the radius R. This is any point on the circle with the coordinates of X, Y. From here, we can draw a right angle triangle where this is A, this is X. Therefore, this length will be X minus A. This is B, this is Y, and this length will be Y minus B. Based on Pythagoras theorem, we can form the equation which is x minus a squared plus y minus b squared equals r squared. So this is the equation of a circle in standard form. We can continue to expand the bracket, which will get x squared minus 2ax plus a squared plus y squared minus 2by plus b squared equals r squared. Then we rearrange the equation becomes x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equals 0. So let the center of the circle C coordinates as negative g, negative f. Then we just substitute the a as negative g, the b as negative f. The equation becomes x squared plus y squared plus 2gx plus 2fy plus g squared plus f squared minus r squared equals 0. So from here, we can see that the g squared plus f squared minus r squared all are constant. We can just let constant c equals g squared plus f squared minus r squared. Then the equation becomes x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is the equation of a circle in general form, where the r equals square root of g squared plus f squared minus c. So from here, you need to know that there are two types of equation of a circle. The first type is the standard form and the second type is the general form. So I would suggest you to memorize the first type because it is easier to remember, and you can also derive the second type of the equation of a circle from the standard form. Now, let's discuss how to determine the position of a point. There are three possible cases. So let point P as any point. Case number 1, if point P lies inside a circle. So to illustrate this case, so this is the circle, this is the center, and this is point P. So point P is inside a circle. So from here, this is a radius r. We can see that the length CP is less than r. Case number 2, if point P lies on the circumference of a circle. So to illustrate this case, this is the circle with the center C, and this is point P. This is the length of PC, and this is the radius r. So from here, we can see that the length of CP equals the radius r. Case number 3, if point P lies outside a circle. So if this is the case, here is how it looks like. So this is a circle with the center C, And this is point P, which is outside of a circle. This is the length of CP, and this is the radius R. We can see that CP is greater than R. So from here, we can actually determine whether the point P is inside a circle, on the circumference of a circle, or outside of a circle by comparing the line CP with the radius of the circle. Tangent and normal at a point on a circle. So let's say this is a circle with the center C. This is the tangent where it touches the circle at one point, point P. So we can join point C and P with a straight line, and it should be perpendicular with the tangent. So the line CP is the normal at the point P on the circle. So from here, the normal is always perpendicular with tangent and passes through the center of the circle. So by applying this concept, we can determine the coordinates of point P by solving simultaneous equation of the tangent and circle. So since the equation of a circle is a quadratic equation, when we solve simultaneous equations for the tangent and circle, right, we'll get the discriminant b squared minus 4ac equals to 0. Now, let's look at one example to find the equation of a circle and determine if a point lies on, inside, or outside of a circle. A circle has a center with the coordinates of -2, 1, and passes through the point with the coordinates of 10, 6. 1. Find the equation of a circle and determine if the point 15, 12 lies inside the circle, on the circumference of the circle, or outside the circle. Here is the solution. So for the first one, we want to find the equation of a circle. We need to know the coordinates of the center of the circle and the length of the radius. From here, we already know the coordinates of the center, which is -2, 1. So we need to find the radius. To find the radius of the circle, we can find the distance between the center and the point given with the coordinates of 10, 6. So the r will be equals square root of 10 minus -2 square plus 6 minus 1 square, and we get r equals to 13. Then we apply the equation of the circle with the standard form, which is x plus 2 square plus y minus 1 square equals to 13 square. We can expand the equation and rearrange the equation, which becomes x squared plus y squared plus 4x minus 2y minus 164 equals 0. Number 2. To determine if the point is either inside the circle, on the circumference of the circle, or outside the circle, we need to find the distance between the point and the center of the circle. So for this case, it will be square root of 15 minus -2 square plus 12 minus 1 square, and we get the distance is 20.24. We compare this distance with the length of the radius, which is 13, and we find that this distance 20.24 is greater than 13. So we can make the conclusion that the point lies outside the circle. Now let's look at this example to find the radius and the coordinates of the center of a circle. Given that the equation of a circle C1 is x squared plus y squared minus 5x minus 8y plus 16 equals to 0, find the radius and the coordinates of the center of C1. The equation of the circle C2 which is a reflection of the circle C1 in the line y equals -1. Here's a solution. To find the radius and the coordinates of the center of C1, there are two methods. Method 1, we use the formula. From this equation, x squared plus y squared plus 2gx plus 2fy plus c equal to 0, we can compare this formula with the equation given. We find that 2g equals to -5. The g is -5/2. 2f is -8. F is -4. Therefore, the center of the circle is 5/2, 4. The radius is equals square root of g squared plus f squared minus c. So we substitute the values of g and f inside this formula. We get r equals square root of -5/2 square plus -4 square minus 16. And the r equals to 5/2 units. We also can use method number 2, where we do the completing the square for the equation given, which is x squared plus y squared minus 5x minus 8y plus 16 equal to 0. Rearrange the equation, which will becomes x squared minus 5x plus y squared minus 8y plus 16 equals to 0. Now we can start to do the completing the square, which will becomes x minus 5/2 square minus -5/2 square plus y minus 4 square minus -4 square plus 16 equals 0. Then we can rearrange the equation, which becomes x minus 5/2 square plus y minus 4 square minus 25/4 minus 16 plus 16 equal to 0. And the equation will become x minus 5/2 square plus y minus 4 square equals 25/4. From here, we can get the center is 5/2, 4. And the radius is square root of 25/4, which is 5/2. So I will prefer method number 2 because we don't have to memorize the formula. We can just doing the completing the square to get the coordinates of the center and the radius. Solution for number 2, we need to find the equation of the circle C2, which is a reflection of the circle C1 in the line y equals to -1. So now let's illustrate this condition on this diagram. So this is the circle C1 with the center 5/2, 4, and the radius is 5/2. This is the line of reflection, which is y equals to -1. And now we want to determine the image of this circle. So this is how we determine. Now the distance between the center of the circle C1 to the line of reflection is 5 units. Therefore, the center of the image of the circle will be 5 units as well below the line. And this will be the center of the circle C2. Okay, from here, so this will be -6. Therefore, the coordinates of C2 will be 5/2, -6. The radius will be the same, which is 5/2. Hence, this is the image of the circle C1, which is C2. So now, we already know the center of the image is 5/2, -6. And the radius is 5/2. So we can form the equation, which will becomes x minus 5/2 square plus y plus 6 square equals 5/2 square. We can expand the equation. x squared minus 5x plus 25 over 4 plus y squared plus 12y plus 36 equals 25 over 4. So 25 over 4 cancel with 25 over 4. The equation becomes x squared plus y squared minus 5x plus 12y plus 36 equals 0. So this is the equation of the circle C2. Now let's look at this example, which is an application of tangent in a circle. Here is the question. A circle has an equation of x squared plus y squared minus 12x minus 4y plus 36 equals 0. 1. Find the coordinates of the center of the circle. Hence, explain why the circle touches a point P on the x-axis. 2. Find the coordinates of point P. 3. Find the equations of the tangents to the circle which pass through the origin. Here is the solution for number 1. I hope that you should know how to find the coordinates of the center. So this is the given equation, x squared plus y squared minus 12x minus 4y plus 36 equals to 0. We can rearrange this equation, becomes x squared minus 12x plus y squared minus 4y plus 36 equal to 0. The reason we rearrange this equation because we want to do completing the square. Hence now it becomes x minus 6 square minus 6 square plus y minus 2 square minus 2 square plus 36 equals to 0. So this 6 square cancel with 36 and the equation becomes x minus 6 square plus y minus 2 square equals to 4. From this equation, we can get the coordinates of the center, which is 6, 2. So we also know that the radius is square root of 4, which is 2 units. So this is also the y coordinates of the center. Therefore, the circle touches the point P on the x-axis. So solution number 2, we can draw the picture to see to illustrate the condition. So this is the center. This is a circle with the center C, coordinates as 6, 2. This is point P, right? And we know that the coordinates of P will be 6, 0. So this is the solution number 3. To find the equation of tangents to the circle which passes through the origin. So the equation of the tangent passes through the origin will be y equals mx because the origin coordinates is 0, 0. So this is my first equation. And the equation of the circle given is x squared plus y squared minus 12x minus 4y equal, plus 36 equal to 0. This is the second equation. We can substitute the first equation into the second equation, which will become x squared plus mx squared minus 12x minus 4mx plus 36 equals 0. So we can factorize the x squared, which becomes 1 plus m squared x squared, and also factorize the x, it becomes minus bracket 12 plus 4m x plus 36 equal to 0. From here, the a is 1 plus m squared, the b is negative 12 minus 4m, and the c is 36. Since the line is a tangent, therefore the discriminant b squared minus 4ac is equals 0. So it will be bracket negative 12 minus 4m squared minus 4 bracket 1 plus m squared times 36 equals to 0. So we can solve this equation by expanding the bracket, which becomes 16m squared plus 96m plus 144 minus 144 minus 144m squared equals to 0. So 144 minus 144, and it will be 96m minus 128m squared equals 0. Simplify, becomes 3m minus 4m squared equal to 0. we factorize the m, and it will be m times 3 minus 4m equal to 0, m equals to 0, or m equals to 3 over 4. Therefore, the equations of the tangents will be either y equal to 0 or y equals to 3 over 4x. Here are a few questions that you can try it yourself. Question number 1. The equation of a circle is x squared plus y squared equals 4x plus 4y plus 17. 1. Find the coordinates of the center of the circle and its radius. 2. Show that the point A with the coordinates of -2, -1 lies on the circle. 3. Find the equation of the line which passes through both point A and the center of the circle. You can pause the video and try to solve it yourself. Here is the solution. 1. So to find the coordinates of the center of the circle and the radius, first we have to rearrange this equation, which becomes x squared minus 4x plus y squared minus 4y equals 17. Then we perform completing the square, which becomes x minus 2 square minus -2 square plus y minus 2 square minus -2 square equals 17. So simplify this equation, we get x minus 2 square plus y minus 2 square equals 25. From this equation, we can determine the coordinates of the center is 2, 2, and the radius is 5. Number 2. So we need to find the distance between point A and the center. By using the Pythagoras theorem, we will get square root of -2 minus 2 square plus -1 minus 2 square, and the distance is 5 units. Now we compare this distance between point A and the center with the radius, and it is equals to the radius r, which is 5 units as well. So we can say that point A lies on a circle shown. Number 3, find the equation of the line which passes through both point A and the center of the circle. So first we need to determine the gradient of the line, which is m equals -1 minus 2 over -2 minus 2. We get the gradient is 3 over 4. So now we can form the equation by using this formula, y minus y1 equals m bracket x minus x1. We can use the coordinates of the center 2, 2. Therefore, the y1 will be 2, the x1 will be 2. Then this equation becomes y minus 2 equals 3 over 4 bracket x minus 2. So y minus 2 equals 3 over 4x minus 3 over 2. We make the y the subject, so y equals 3 over 4x plus 1 over 2. So this is the equation of the line, which passes through both point A and the center. Do you get the answer correctly? Question number 2. A circle C1 with center A7 passes through a point P for -2. The equation of the tangent to the circle at P is x equals 3y plus 10. 1. Show that A equals 1. 2. Find the equation of circle C1. 3. Find the equation of C2, which is a reflection of C1 in the line x equals -1, leaving your answer in the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. You can pause the video and try to solve it yourself. Here is the solution. Number 1, we want to find the gradient of the normal, which is the gradient of the line which joins the center and the point P. Therefore, the gradient will be m2 equals 7 minus negative 2 over a minus 4. And we get m2 equals 9 over a minus 4. We know that normal is perpendicular to tangent, so which means m1 times m2 equals negative 1. So from the equation of the tangent given, we know that the gradient of the tangent is 1 over 3. Therefore, 1 over 3 times 9 over a minus 4 equals negative 1. Now we can solve this equation, which becomes 9 over a minus 4 equals to negative 3. 9 equals 12 minus 3a. Hence, 3a equals to 3, a equals to 1. So we've proven that a equals to 1. 2. To find the equation of circle C1, we already know that the coordinates of the center is 1, 7, as we have shown that a equals to 1. Now I want to find the radius of the circle, which is r square equals 1 minus 4 square plus 7 plus 2 square. So again, we can use the coordinates of the center and the point P to find the radius. And we get r square equals to 90. Therefore, the equation of the circle will be x minus 1 square plus y minus 7 square equals 90. Number 3. To find the equation of the circle C2, right, we can determine the coordinate of the center C2, which is negative 3, 7, as it is a reflection of reflection of C1 in the line x equals negative 1, and the radius remain the same. Therefore, the equation of the circle C2 will be x plus 3 square plus y minus 7 square equals 90. Now we can expand the bracket, which becomes x squared plus 6x plus 9 plus y squared minus 14y plus 49 equals to 90. Rearrange the equation, x squared plus y squared plus 6x minus 14y plus 9 plus 49 equals to 90. And it will become x squared plus y squared plus 6x minus 14y minus 32 equals to 0. So that it is in the form required. So this is the equation of C2. Do you get the answer correctly? Question number 3. So this is the diagram shown. In the diagram, the point P, 4, 4, and the origin are the opposite ends of a diameter of a circle. 1. Find the equation of the circle. 2. Find the equation of the perpendicular bisector of OP. The perpendicular bisector of OP intersects the circle at Q and R. 3. Find the coordinates of Q and of R, and hence state the geometrical shape of the figure OPQR. You can pause the video and try to solve this question yourself. Here is the solution. To find the equation of a circle, we need to know the coordinates of the center and the length of the radius. So therefore, the length of OP is square root of 4 square plus 4 square, which is square root of 32. This is the length of the diameter. Okay, we can simplify, becomes 4 square root of 2. Therefore, the radius will be 2 square root of 2. Then the center of the circle C is the midpoint of OP. So the coordinates will be 4 over 2, 4 over 2, which is 2, 2. Hence, we can form the equation of the circle, which is x minus 2 square plus y minus 2 square equals 2 square root 2 square. It will be x minus 2 square plus y minus 2 square equals to 8. Number 2, find the equation of the perpendicular bisector of OP. So first we need to find the gradient of OP, which is m1 equals 4 over 4, and the answer is 1. Then we want to find the gradient of the perpendicular bisector, which is m1 times m2 equals to -1, and we know m2 will be -1. So this perpendicular bisector will pass through the midpoint of OP, and the gradient is -1. So we can apply the formula y minus y1 equals m2 x minus x1. So substitute the coordinates of the center OP, which is 2, 2 into x1 and y1, and the gradient m2 is -1. So the equation becomes y minus 2 equals -1 x minus 2. We make y the subject, so the equation of the perpendicular bisector will be y equals -x plus 4. Here is the solution for number 3. So we know that the equation of the circle is x minus 2 square plus y minus 2 square equals to 8. And the perpendicular bisector is y equals -x plus 4. Okay, we can solve the simultaneous equation of these two equations. This is equation number 1 and this is equation number 2. Now I want to substitute equation number 2 into equation number 1. And it will be x minus 2 square plus -x plus 4 minus 2 square equals to 8. Rearrange, it will be x minus 2 square plus 2 minus x square equals 8. Or x minus 2 square plus x minus 2 square equals to 8. We get 2 times x minus 2 square equals to 8. Therefore, x minus 2 square equals to 4. So x minus 2 equals plus minus square root of 4, which means x minus 2 equals to 2, or x minus 2 equals to -2. So x will be 4, or x will be 0. And hence y will be 0, or y will be 4. Therefore, r will be 4, 0, and q will be 0, 4. So now we can label the point r and the point Q on the diagram, which looks like this. And from here, we can join them together, and we can say that OQPR is a square. Do you get all these answers correctly? Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.